Welcome to this brief introduction to Matlab by Dr. Moses Mayfield. In this brief tutorial, we are going to learn the basics of Matlab and how to carry out some basic operations in the Matlab environment. Matlab stands for Matrix Laboratory and is well suited for carrying out matrix operations, which is suited for a course such as advanced estimation method and analysis, especially when it has to do with large matrices. It has many functions and toolboxes to help in various applications, as well as allows you to solve so many technical computing problems, especially those with matrix and vectors formulas, in a fraction of time it would take to write a program in other conventional non-interactive languages such as C, Fortran, Java, and the likes. So, Matlab is a high-performance language for technical computing. It's put together computation, visualization, programming in an easy-to-build environment where problems and solutions are expressed in familiar mathematical notations. Typically, these include maths and computation algorithm development, modeling, simulation, prototyping, data analysis, and other scientific computations. Of course, it also supports the development of graphical user interface, what we refer to as GUI. The Matlab system consists of basically the following main parts: desktop tools and development environments that allow you to type your code, edit, and access help functions. It has a very rich mathematical functions that allow you to work on sophisticated functions such as matrix synthesis, matrix eigenvalues, Bessel function, as well as fast Fourier transforms. So Matlab is a high-level matrix or array language which supports control flow statement, function structures, input-output, as well as object-oriented programming paradigm. It supports graphics, so you're able to plot and carry out complex graphical supports. It also allows you to work with external interfaces such as those from C and other languages. This is the basic Matlab window. You have the command prompt that allows you to use Matlab basically as a calculator where you can type your code and then it's executed immediately. You have the path to current folder showing you the current working directory. You have command history that shows you the history of codes you've typed over time. And then you have the workspace variable that show you the various variables you've created. And here is the help and search bar where you can simply type a keyword to search for help on that topic. So this shows the same window from another view. So you have the command window, you have the current directory, you have the workspace, and then you have command history, showing historical records of previous commands. So, as said earlier, Matlab is basically a high-level language which has many specialized toolboxes for making things easier for us, especially when it has to do with matrices, graphics, and other high computational requirements. What are we interested in? Well, Matlab is actually very broad, but we want to basically introduce ourselves to the basics in this tutorial. So Matlab is made up of M files, which you can use to create functions. You have the command line and then mat files when you save consecutive commands. It also supports input and output. So the command line works like the DOS command window we have in a conventional window. It supports storage and loading of existing mat files as well. Unlike other languages where you have to define the type of variable you're using, where you have to specify if a variable is an integer, is a string, double or float. In Matlab, you don't need to define the type of variable. You just create the variable and the program is able to recognize them automatically. So we'll talk about working with matrices at this point in time. Since Matlab makes extensive use of matrices, the best way for you to get started with Matlab is to learn how to handle matrices. Basically, matrices are separated element-wise using blanks or commas. Then to indicate the end of a row, you use a semicolon, okay, and then you surround the entire list with square brackets. For example, the first row of this matrix is 16, 3, 2, 13. The semicolon indicates the end of that row. The next row, you type 5, 10, 11, 8. Okay. Likewise, the third row, you have 9, 6, 7, 12. The fourth row, 4, 15, 14. So by looking at this matrix has 4 rows, 1, 2, 3, 4, and then 4 columns, just 1, 2, 3, 4. So if we type in this into the Matlab command window, we have this showing the rows and the column. So once you have entered the matrix, it is automatically remembered in the Matlab workspace. And subsequently, you can refer to it by just typing the name of the matrix, or what we refer to as a variable name. It's also important to note that variable names are case sensitive. That means capital letter A is not the same thing as small letter a, so it is case sensitive. So generally, like we have in most of our calculators, when you don't specify the output, the variable, Matlab automatically uses the variable called answer. So you'll see that in a moment. It's also possible to find subscripts, that is part of a matrix, where you define it by the row number and the column number. Okay. So like the previous matrix, we have the element at row 1, column 4, and we added to the element at row 2, column 4, likewise row 3, column 4. That means we are actually adding the element of the fourth column. Okay. The colon operator allows you to type in a range of numbers. For example, 1 colon 10 will give you the range of numbers from 1 to 10. You could also specify an increment, okay, either positive or negative. So from 100, we want to step down by 7 till we get to 50, and this gives us 103 up till when it's 50. The numbers can be represented either as integers or as decimal, and then Matlab also supports complex numbers where you use I or J to represent complex number. However, Matlab stores the real and imaginary parts of a complex number, so you can read out the real part and also read out the imaginary part. It's also possible to load text file using the load function in Matlab. Okay. M files are basically Matlab codes that you create and you save as .m. So when you create your own programs, you save it as .m so that Matlab will recognize it as M files. Okay. Arrays. Arithmetic operations on arrays are done elements by elements. individual elements are created on element by element wise, and then add, multiply, subtract as required. So we have an example here of some of the basic statistics you can do with Matlab. So we have an example with a dataset containing heart rate, weight, and then hours of exercise per week. Okay, so the first column represents the heart rate, the weight, and the hours of exercise. So we may want to see the mean. Okay, the mean of each column. So when you say mean, it gives you the mean of each of the column, and you also want to see the standard deviation of each of the column. Okay, so these are basic operations you can quickly carry out in Matlab. Matlab variable names. It's important to note that variable names are case sensitive, like as mentioned earlier. So you have to differentiate between lowercase and uppercase. And variable names can contain up to 63 characters. However, it's important to give names that are descriptive so that you can easily know what such variables refer to. Variable names must always start with a letter, then followed by other letters, digit, and underscore. Now, Matlab also has special variables that are reserved, so you can't use them as a variable name. For example, answer, pi, infinity, none, representing not a number, among other numbers. Yeah, this shows the basic mathematical operators used in Matlab. So the exponential power is represented by the exponential character, or this, if you want to do the element wise, multiplication is represented by a series, division, header, place, forward or backward slash. Okay. Subtraction, addition, assignment, where you assign A equal to B, you use the equal to sign. So other Matlab symbols. The double forward arrow represents front, meaning Matlab is ready to accept your code. The three dots are used to continue on the next line when your line of code is too long and you have to break it into multiple lines. Then if you have a series of codes or statements, you can separate them using the comma sign. The percentage sign is used as comment to describe a portion of code, like you want to explain what a particular line of code does. You use percentage sign. And then if you don't want your output displayed in the command window, you suppress it using the semicolon, because sometimes there's so much output that you don't want it displayed on the command window, so you suppress it with the semicolon sign. Note that the computation will be done, but the result will not be displayed on the command window, while the calling operator actually represents that. Welcome to the Matlab environment. As we saw earlier in the PowerPoint, this is the Matlab environment. Okay, you have the current folder that shows the current working directory where your codes will be saved. You have the command window that allows you to use Matlab as a calculator. Okay, you can easily carry out computation in the Matlab environment. Okay. And then you have the workspace. The workspace keeps record of the variables you've created. So since we've not assigned any variable so far, it is using the default variable name answer. If for example we say A equal to 5, then A is added to the variable list. Okay. You can simply clear the command window by typing this command cls clear screen to clear the command window. Okay. Here you can rename variable name. Okay. And then it's also important to know that Matlab is case sensitive. So A can be 5, and then capital A is assigned to something else, let's say 10. So we have A plus capital A giving us 15. Small letters are different from capital letters, which makes Matlab case sensitive. Okay. So basically, to carry out matrix operations, we define a matrix, let's say matrix A equal to, like we saw, the elements of the rows are separated either by comma or by space. So we can say A is 1, 2, 3 for the first row, the second row 2, 3, 4, and the third row 4, 5, 6. So if we press enter, we have the value of A display. However, there are times you don't want to display your output, so you suppress the output using semicolon. So if we create another matrix B and say this is, so let's try using the comma 2, 1, 1, 1. The next row maybe 2, 2, 2, and the third row 3, 3, 3. So we can suppress this output so that Matlab don't have to display it by typing the semicolon here. So if you do this, look at the workspace to your right. B is created but it's not displayed because we have suppressed it here so that we don't have too many output. At any point in time we want B, we can simply type it and we have it here. So with its two matrices created, A and B, you can carry out your basic matrix operations. For example, A plus B, you can decide to say matrix C equal to A plus B. Okay, matrix D equal to A minus B. Okay, you can carry out the determinant of a matrix simply by typing delt A. Case sensitive, take note. So that gives us the determinant of A. You can simply type this to get the determinant of B. The determinant is 0 in this case. Okay, you can carry out transpose. Okay, by using hyphen. So this will give us A transpose. This will give us B transpose. Okay, so assume we have a matrix of weights 1.5, 1.0, and then 1.6. So let's suppress this. Okay, incorrect use of equal to. So let's see what's wrong. Alright, so we have this as the weight, and then we want to create the weight matrix. You can do that by saying P equal to diagonal of the weight. So it will create a diagonal matrix, okay, with the weights listed diagonally. Okay, assuming we have equal weights, that means the weights are 1 for a 3 by 3 matrix. We can easily create that using the special function I and say 3. So this will create a 3 by 3 matrix with value of 1 in the diagonal for a matrix of equal with. Okay, the inverse of a matrix is created simply by using this function inv a. Okay, so since the determinant of b is 0, let's see what happens if we try to look for the inverse of b. Okay, yeah, because the determinant of b is 0, so we should expect this. To create eigenvalues, you simply use IEG of a and you have them created. So it's that easy to work with. As you practice, you will get more familiar with most of the operations. So you can change our current directory. Okay, so let's clear the screen. And then you can clear this variable by selecting and then deleting. Be sure you want to do that. Okay, the next thing we want to look at is working with M files. So you can see sometimes you want to go back to previous command and then you may have cleared it. So one way to do that is to save that is to work with M files. So basically go to new script. It will create the file. You can save it. Matlab practice. So in this case, you can type your codes here easily. Okay, suppress, so we don't have to display the output. B equal to but take note, nothing has been created. We've only typed the codes here. To execute a particular line, you can easily highlight the line, right click and say evaluate selection, or you press F9 on your keyboard. So if we evaluate selection, that means we just want to evaluate this line of code. So A is created. To evaluate B, we would highlight this, okay, and then to evaluate multiple lines, select all and click on evaluate. Okay, so the codes are repeated here, but you have them here in order to make reference to. So we talk about comments. There are times you want to explain lines of code. Okay, so you can type the comments before the line of code, like for example, this symbol represents comment in Matlab. Say creating matrices. So somebody going through your code, you know that the following lines after this explanation is that you're trying to create matrices. And then there are times you want to explain specific lines. For example, this code, you use comment to explain by the side that this is determinant of matrix A. Okay, so comments are usually used to explain sections of code. Okay, you could also use it to document your code. For example, you say author date so you can highlight, okay, and say comment, or you use the shortcut Ctrl+R. So this will help you document and explain the section of code. Basically, that is what comments do. Okay, so you can create a special matrix P equal to I3. So if you want to see the output, you don't put a semicolon, you highlight and you evaluate, create it for you. So to clear your variables, you can use the function clear all. Either you type it here and you execute, or you type it directly in your comma window, clear all. Okay, and then you can clear the comma window using this function. So let's assume we have our P, W, LB, and B in text file. Let's see the content. Okay, so we have them in text file. This is P, we have our B, and we have our LB, and we have our W given, all in the text, in the respective text file. So Matlab allows you to load such file from text file. Okay, so let's put a comment header here, loading variables from text files. Okay, so the comment here is explaining what we want to do. So to load the variable, you use the function load, and then in bracket the file name. So you can see the hints given by Matlab showing you whether you put the file name and the variable, and other option. So we want to load w.text. Okay, if we do this and run this line of code, take a look at the workspace. Matlab loads the file and then assign the variable name to it. So if we don't want this particular variable name, we could have changed it as weight, for example, equal to load. So by so doing, you have assigned the content of this file to the variable called weight. Okay, remember we've created this earlier. But if you just use the function load, then it assigns the file name as a variable name. Okay, so you could also load other files. The P, you could load the original observation, B. Okay, and then you run them. So Matlab will load all of them. So once you have them loaded from your text file, you can easily come and then write your code to execute what you want to compute. Okay, variable A. Okay, we don't have our A matrix, so we are expected to have A. You can see unrecognized function variable A, because we have not been able to define A in our as part of our variables. Okay, so to do that, let's quickly bring our variable A into the workspace. So with that, we can come back here and execute. Okay, and we have our matrix X. It's not showing in the comma window because we have suppressed it. We can simply type X here and then you have it. So basically, these are some of the quick things you can do with Matlab. You should know that the application of Matlab is far much more than this. Okay, because it supports you to actually plot. Okay, you can plot and you can do so many graphical analysis in the Matlab environment. Okay, you can actually plot and then see what happens. Okay, you could edit your plots. Alright, this is a property editor. So you want to change the line type. Okay. You could also put different form of markers. So you'll see more of this as you practice. Okay. So you can plot, you can find mean. Okay, you can find standard deviation. Okay, and other statistical analysis. Okay, you can carry out other kinds of plots. For example, you can plot bar charts to see the various value of the computed parameter x1, x2, x3. Okay, you could actually add a legend so that each of them is labeled. Okay. Likewise, you could create a pie chart of the computed parameters. Okay, you have that. You can simply add a legend. Alright, so you have that. If you wish, you could put a title for your plot. Okay, and you have it. So this is just a basic introduction. As you practice more with Matlab, you get to see more of the sophisticated things you can do with Matlab. Okay, thank you for listening.